There is a very old argument in engineering about whether it is better to build a tool that can do everything or a tool that can do one thing perfectly. A Swiss Army knife will get you out of most situations. But if you actually need to cut a plank of wood, you would trade every gadget on it for a single, plain, excellent saw. This month, a company most people have never heard of made an enormous bet that the world of artificial intelligence has reached exactly that moment. The moment where it wants the saw. Now, I should say where I stand, because this video is going to end with an opinion. I think this bet is one of the most interesting things happening in computing, and that it is either going to look visionary or faintly ridiculous within a couple of years, with very little room in between. And I think the sheer amount of money lining up behind it is telling us something real about where the whole industry now believes its future lies. Because almost all of the AI you have ever used runs on a kind of chip, that is, by design, a generalist. It is called a graphics processing unit, a GPU, and its great virtue is flexibility. It was built to do a huge range of mathematical work, which is exactly why one company that makes them has become one of the most valuable on earth. If you want to run more or less any AI idea anyone has, you can run it on these chips. They are the Swiss Army knife, and for years that flexibility has been the entire point. And if you asked why anyone would want something less flexible than that, the answer sounds almost too simple. But you know what? It is simple. Nearly every important AI system of the last few years, the chatbots, the image generators, the coding assistants, is built on one single underlying design, an architecture called the transformer. The generalist chip runs the transformer, but it also carries the weight of being able to run 1,000 other things. It is no longer being asked to do. So here is what we are going to do. First, the specific bet this company has made and the chip it has actually built. Then, why doing less can make a machine dramatically faster. And finally, the big one. The single assumption the entire bet rests on, and what happens to all of it if that assumption is wrong. First up, the company. It is called Etched, and until very recently, it barely existed in public. This month, it came out of stealth with something most chip startups never reach, which is a finished working chip manufactured by the same Taiwanese company that makes the most advanced silicon on the planet. And it did not arrive quietly. It arrived with around $800 million raised and more than $1 billion of orders already signed before most people had heard the name. And what they built is deliberately, almost aggressively narrow. Where a general chip keeps its options open, Etched took the transformer, that one dominant design, and etched it directly into the hardware. The chip is called Sahu. It cannot run the huge variety of things a general chip can. It does the transformer and effectively nothing else. That is not a limitation they are apologizing for. It is the entire product. And to understand why anyone would deliberately cripple a chip like that, you have to understand where the cost in modern AI has quietly moved. There are two phases in the life of one of these models. Training, which is the enormous one-off effort of building it, and inference, which is the actual running of it every single time you or anyone else asks it a question. Training happens once. Inference happens 1 billion times a day, forever. And that changes everything about what a chip is for. Inference is now the part that runs constantly, and so it is the part where efficiency compounds. Shave a little cost or power off each answer, and across billions of answers a day, you have changed the economics of the entire field. The race has quietly moved from who can build the cleverest model to who can run it, over and over, for the least money and the least electricity. So here is why doing less can make you faster. A general chip, every time it works, spends a portion of its effort just deciding what kind of work it is about to do and shuffling things into place to keep all its options open. That flexibility is not free. It costs silicon and it costs power on every single operation. A chip that only ever does one thing can throw all of that away. It never has to ask what it is doing because the answer is always the same. Let me put that physically. On a general chip, only a modest fraction of the silicon is doing the actual transformer maths at any instant. The rest is overhead, plumbing, and generality you are paying to keep available. Burn the transformer directly into the hardware, and you can hand far more of the chip to the one calculation that matters. Same physics, same factory, radically more of the machine pointed at the single job. And this is why the money is behaving the way it is. Even as it was emerging, the company was reportedly in talks for further funding at valuations climbing into the tens of billions of dollars, with some of the most serious names in finance and technology competing to get in. You do not have to believe those numbers to notice what they mean. A lot of very well informed people are betting large that specialized inference silicon is where the next decade of value sits. And honestly, this is the part where I want to slow the excitement down, because the whole thing rests on a single, load bearing assumption, and almost no coverage says it out loud. The entire bet depends on the transformer remaining the dominant design. Etch a thing into silicon, and you gain enormous speed, but you lose the one thing a general chip never loses, which is the ability to change your mind. A GPU can run whatever comes next, this cannot. Now, to be fair to the bet, that assumption is not reckless. The transformer has been the backbone of this field for years, an eternity at the current pace, and every attempt to dethrone it so far has either failed or quietly turned out to be a variation on the same idea. Betting that it stays central for the few years it takes a chip to earn out is not obviously wrong. It might be the safest guess available. Specialization has also, historically, won these fights before, once a workload becomes big and stable enough. But there is a real ghost in this story, and its name is worth remembering. For years, the world ran a specific kind of specialized chip to do exactly one lucrative job, until the job changed underneath it, and warehouses full of purpose-built silicon became close to worthless almost overnight. Specialized hardware is a magnificent servant of a stable problem, and a catastrophic hostage to a changing one. The whole question is, which kind of problem the transformer turns out to be. But I think the deeper point survives whichever way this particular bet lands. What you're watching is a field growing up. Young technologies run on generalist hardware, because nobody yet knows what matters, and you need to keep every option open. Mature technologies get their own dedicated silicon, because the thing they do has become important enough and stable enough to be worth carving into stone. A specialized chip is not just a product. It is a claim that an idea has stopped being experimental and started being infrastructure. So the thing to watch is not really this one chip or even this one company. It is the bet itself, repeated. If more of these narrow transformer-only machines appear, and the giants start building their own, then the industry will have quietly voted that this design is permanent, the saw the world actually needs. And if a genuinely new architecture arrives and sweeps the transformer aside, a great deal of very expensive, very fast, very specialized silicon will become the most advanced answer to a question nobody is asking anymore. Either way, the size of the bet is the real news. Somebody just wagered billions that the age of keeping your options open is over.